Hello Year 9, welcome to today's lesson. This is going to be the first of several on simultaneous equations. But before we start, I just want to give you a quick reminder that if you have any problems with the work that you've been doing, you need to contact your own teacher, and you can do this on the email. So, equations such as this one have two variables. That's the x and the y, two things that we don't know. There is no unique solution to this equation by itself. So there's no one single solution. For instance, x equals 4 and y equals 5 is a solution to this equation, and that is because 5 times by 4, 5 lots of x, and 2 lots of 5 is going to be 20 plus 10, which is 30. So 5 lots of that x and 2 lots of that y make 30. So they are a solution. But it's not the only one. For instance, x is equal to 6 and y equals 0 is a solution. 5 lots of 6 is 30 and 2 lots of nothing added together still 30. Also, x is equal to 0 and y is equal to 15. 5 lots of nothing is nothing. 2 lots of 15 is 30, so nothing and 30 is 30. So all these are pairs of solutions. And there are many pairs that fit this equation. So, when there are two variables and we want to find a particular set of solutions, so a specific value of x and y, we need two equations. And this pair of equations is called simultaneous equations. They're called simultaneous equations. So let's have a look at a pair of simultaneous equations. I'll use the same one I had before. 5x plus 2y equals 30. And 5x plus 6y equals 70. So I have two equations. Now, excuse me, when I'm solving simultaneous equations, we always number them. In this case 1 and 2, because there are two equations. We can see here that the number of x's in the first equation and the number of x's in the second equation are the same. They're exactly the same. So the only difference between the top equation and the bottom equation is the number of y's, and that corresponds to the difference there. So I'm going to find a difference. I'm going to do equation 2, take away equation 1. That's because there is a greater number of y's in the bottom than there is in the top. So, always write down what it is you're doing. So I'm doing equation 2, take away equation 1. 5x take away 5x, nothing. 6y take away 2y is 4y, equals 70 take away 30 is 40. And now I've got a very simple equation that I can solve. Y will be equal to 10. And if y is equal to 10, that's true for both of these equations, I need to find x. So I substitute this value of y back into either one of these equations. So I'm going to substitute back into, so substitute into 1. And so I've got 5x plus, instead of 2y this time, I've got 2 times by 10. And that's equal to 30. So 5x plus 20 is equal to 30. 5x is equal to 10. X must be equal to 2. And then I'm going to do a check. If I've got that right, that pair of values will work for both of those equations. I know they work for equation 1 because that's what I've just used. So I'm going to do a check. Check. And I'm going to go into the other equation. So equation 2 says 5x, 5 times by 2 and 6 times by 10. That's 10 plus 60, which is equal to 70. Is it supposed to equal 70? Yes, it is. I've got it right. So this method of subtracting one equation from the other to get rid of one of the variables is called elimination. As by doing the subtraction here, we've managed to eliminate x. Now it's your turn. You're going to pause the video and you're going to have a go at exercise 10b on page 181. Just question 1. Spend 10 to 15 minutes just on question 1. Check your answers as you go. The answers are attached to class charts, and so you don't get loads wrong. And then if you're not sure, I'm going to do question 1a as an example on the video, just in case. If you don't need to see it, pause it and you can skip past that. So pause your video now and have a go at question 1. So here's our extra example. This is question 1a from exercise 10b. So as you can see, this is the pair of equations that we need to solve. As before, label them 1 and 2. So I can see here that there is no difference between the a's, so if I subtract, I will eliminate a. I'm going to do equation 1, take away equation 2 because it's the biggest number and I will end up with a positive number of b's. So equation 1, take away equation 2, a take away a is nothing, it's been eliminated. 6b take away 3b is 3b. 31 take away 16 is 15. So b must be equal to 5. Then choose one of the equations to substitute back into. It does not matter which one. I'm going to go in the one with the smallest numbers because it's a bit easier. So I'm going to substitute into equation 2. So I've got a plus 3 lots of b. So 3 times by 5, and that's this equal to 16. So a plus 15 equals 16, which means that a is equal to 1. And then my check, I used 2 there, I'm checking in 1. I've got a plus 6b, so a plus 6b is going to be 1 plus 6 lots of 5, 1 plus 30, 31, which is what it should be. I've got it right. Now you can carry on with the rest in question 1. Now have a look at this example, which is on page 180 in the textbook. You'll notice that if I subtracted the top one take away the bottom one, I'll end up with 3x take away x is 2x, so they're not eliminated. And negative 4y take away positive 4y, so that's going to be negative 8y, which is still not eliminated. So subtracting these doesn't work. However, because these two are the same value, this coefficient of y, the number in front of the y, is the same, and one's a positive and one's a negative, if I take the total of those, then they will disappear. They will be eliminated. 4y and negative 4y, when added together, are nothing. So in this case, I'm going to add them. So in this case, I'm going to do 1 add 2. You choose whichever method, either adding or subtracting, that you need to eliminate one of the variables. So 3x add x is 4x. Negative 4y and 4y when added is nothing, and 22 add 18 is 40. So x is equal to 10. I've found one of them, I now need to find the other. So I'm going to substitute into, doesn't matter which one, but I'm going to substitute into the one without the negative sign because it's a little bit easier. So substitute into equation 2, and I've got x, which is 10, plus 4y is equal to 18. That means 4y is equal to 8 and y will be equal to 2. And I'm going to perform my check. I went into equation 2 last time, so I'm now going to go into equation 1. So 3x take away 4y would be 3 times by 10 take away 4 times by 2. 30 take away 8 is 22. 22 comes to 22. I've got it right. So again, have a pause of the video so you can have a go at question 2 and question 3. Question 3 are mixed. You have to make your mind up whether you're adding or you're subtracting. Those now, I'll give you about 15 minutes, maybe 20 minutes to do those. And once again, if you're stuck, I'm going to do question 2a as an extra example. So here's the first question, first part from question 2. So as with all simultaneous equations, you label them first and then you look to see whether you are going to add or subtract. These numbers are the same, the signs are different, so I'm going to add them so that they cancel themselves out. So I'm going to do equation 1 add equation 2. 3x add 8x is 11x. 2y and negative 2y is nothing when added, and 19 add 58 is 77. So solving that little equation, x must be equal to 7. And again, I'm going to go into the one that doesn't have the negative sign in it. So I'm going to substitute into 1. So 3x is now 3 lots of 7, plus 2y is equal to 19. So 21 plus 2y equals 19, which means that 2y must be negative 2 and y is negative 1. And I'm going to perform my check. Before I went into 1, so I'm now going to go in 2 and just see equation 2 there. So 8x take away 2y is equal to 8 lots of 7 take away 2 lots of negative 1. And here we need to be very careful. 8 7s are 56. I'm taking away 2 lots of negative 1 is negative 2. 56 subtract negative 2 is the same as 56 add 2. That's 58, which is what we needed to get. So we must have got it right. Now if that's a little bit clearer, can you now carry on with the rest of the questions in question 2 and 3? So on to the final part for today's lesson then. Well, being able to form equations like these simultaneous equations is really useful when you need to find two values, and we can make up equations, we can make up with ordinary linear equations. So this example here, again, this is one from the textbook, is a really good way to show this. So Alex plays a computer game. He scored 31 points by destroying 2 planets and 3 satellites, and he scores 45 points by destroying 2 planets and 5 satellites. How many points are scored for destroying a planet and for a satellite? So we need to find the number of points for a planet and the number of points for a satellite. That's 2 things. So we need 2 simultaneous equations. But first of all, let's write down what letters we're going to use. So I'm going to say number of points, or the points scored, points per planet, and Y are the points per satellite. So if I can find X and I can find Y, I've answered this question here. So first things first, destroying 2 planets and 3 satellites, he gets a total of 31. So 2 planets, points for 2 planets, and the points for 3 satellites comes to 31. And the points for 2 planets and 5 satellites is 45. So I have 2 simultaneous equations. And now I've got to decide whether I'm going to add or subtract. Well, none of them have got positive and negative signs. So by adding them, they're not going to cancel each other out. So I'm going to subtract. This has got the biggest number of y's on it. So let's do equation 2. Take away equation 1. 2x take away 2x is nothing. 5y take away 2y is, 3y is 2y is the answer. And 45 take away 31 is 14. Which means that y is equal to 7. So I want to know what y is. I can choose either one of these. So I'm going to substitute back into, I think I'll go into 1. So I've got 2 lots of x, 2x plus 3 lots of y, so 3 lots of 7 is 31. 2x plus 31, oh dear. Is equal to 31. So 2x is equal to 10, x must be equal to 5. That means, once we've done our check, I'm going to go into 2. So 2x plus 5y is 2 times by 5 plus 5 times by 7. 10 plus 35 is 45. So we've got it right. So this tells us that Alex scored 7 points for every satellite he destroyed and 5 points for every planet he destroyed. So the actual method used for solving is no different once you've got your 2 simultaneous equations. You just need to be able to turn the words into 2 simultaneous equations. So your turn now to finish off with the problem solving. Just have a go at questions 4, 5 and 6 in the time remaining. You don't need to bother with question 7. Until the next lesson.